How are we doing? What have I got today? Today I've got the LM317. It's a variable voltage regulator. It's a linear regulator that I've got set up on here on the bench. Just as a note, in this power supply box I've got here, this has got the LM338, which I suppose is the big brother of the 317. The 338 gives about 3 amps of current. The 317 gives about 1.1 amps of current, and there's even a little brother, which is the LM317 LZ, which gives about 100 milliamps. It's a TO90, is it? TO92 package for that one. The LM317 and the 338 are in the TO220 package. So let's have a look at it on the workbench and see what we get. So here we go. Got the LM317 on the bench here. Sit over there, and I've got an LED and a resistor I'm going to test, and that's my pot. So a quick look at the diagram for it. Basically, I'm not going to do any of the maths today. It's very simple maths. It's actually explained on the data sheet. If you get a data sheet for the LM317, how to set it up, what resistors and that to use, and it gives some examples of how it can be used in maybe some other circuits rather than just as a basic voltage regulator. Anyway, there you go, 317. Got a resistor there to the adjust, and what you have there is the input and output and the adjust pin. That's the pin out for it on pretty much all of them. Adjust, output, input. So that's fairly simple. Now with a basic setup, you put in a resistor there. I say you calculate it from the data sheet, and another resistor there, and that'll give you a determined output. Of course, this is meant to be a variable voltage regulator, so you'd put a fixed resistor in there and then put a pot in there. But the way I put this pot in is basically just straight after the fixed resistor. Now the way that this works is it wants to have between these 2 points, the output and the adjust, it wants to have about 1.25 volts. That's what it adjusts to. That's why you have to have a higher input than what you're going to get out. So if you put 12 volts in, you're going to get about 10 volts or so on the output, because that's how it's going to make that adjustment. So there's always 1.25 volts across this resistor. But of course, if I wire it up this way, I'm changing the fixed resistance. It's no longer fixed because that pot will alter that point. So what I've done is to wire it up like this. So that resistance never changes, but this resistance to ground for the adjust to ground will change. And then the top of this pot, the other side of it, is basically floating in the wind. It's just having a happy time on its own. What am I going to put it to? I'm going to start off with an LED resistor, LED, very simple. So let's have a look at that. So I've got the circuit all wired up for this LED. I'm going to use this bit of, I don't know, like tracing paper stuff. I've used it before to cover that up, otherwise when I get it turned on it'll be quite bright. I've got a multimeter here so I can see my output voltage. So I'm going to turn this power supply on. It has got a big noisy fan in it, so I do apologise for any noise. So let's turn this on. And as you can see, I've got 1.25 volts there on the output. The LED is not on. It's not able to be. It's not enough power. I think this is a 1 watt white LED. Don't know the ratings for it. So I've no idea what it's going to take, turn it on, how much current it's going to draw. I have no idea at all. So I'll just slowly turn this up. There we go. It's just come on. You can't really see that. Maybe if I do that, you can see that that is now just come on, and that's about 2.5 volts. If I turn that up, it's certainly going to start to get brighter, so put that on top. and keep turning up the voltage. I've got 5 volts, 6 volts, 7 volts, 8, 9, 10 volts, and that's about it. I've got a bit more turn on the pot, about a quarter of the pot I suppose, quarter of a turn on the pot, but it's not going up anymore. It can't go up anymore because we've got 12 volts coming in and it's about 10.25 volts coming out of it. It's at its maximum use, and that LED is nice and bright. Now I wonder how much current this is drawing. Well, that's quite simple I suppose. All I need to do is to measure the voltage across this resistor. Let's do that now. .5 volts across that resistor, and it's a, what did I put in there? It's a brown green, sort of 1, 5 and a black. It's a 150 ohm resistor. So I've got a 150 ohm resistor with 7.5 volts going through it. Quickly on the calculation, 7.5 volts divided by the 150 ohms gives me 50 milliamps. 50 milliamps, that's brilliant. So that is, and obviously if that's dropping 7.5 and I had 10.25, so 10.25 minus the 7.5, 2.75 volts across that, times by the 50 milliamps, it's going to give me, it's about 137 milliwatts. That's not it's not stressing it at all, that LED. It's quite bright even so, but it does work just fine. And nothing's going to be getting particularly hot. We're not drawing anywhere near the maximum current levels. I say LM317 gives out approximately 1.1 amps. There we go. Let's try it with a resistor. Let's just turn this down. Put just a resistor on the output. Turn that off. Okay, let's change the connections over. Got resistor set up here. This is a 150 ohm resistor. Get that on there. Sorry if the wires are flapping in the breeze. That's why I've got this taped down to stop everything from moving about too easy. So unhook that. Get the other end in there. There we go. Marvellous. So now I can turn this on, and I've got a 150 ohm resistor on the output. So basically I had a 150 ohm resistor here and then an LED. So, but this time the 150 ohm resistor is going to be dropping the whole voltage. So let's turn that on. Now, as you can see, look at this. The output isn't 1.25. This resistor is actually loading the circuit, so it's drawing it down a little bit from its 1.25 reference, which is what you expect. Then I start turning it up, quickly rises up 10.2, and I'm not at the full turn of the pot. I'm probably got half a turn. I'm only able to turn this pot up about halfway before I reach my maximum voltage, which means this little resistor wants to draw quite a bit of current, but the voltage regulator is limiting that voltage to 10 volts. So 10.2 volts, what have I got? So let's do that. 10.22 divided by the 150 ohms means I'm getting out about 68 milliamps through the through that resistor, which is well within what this circuit can cope with. Brilliant. Now there is one thing about this circuit that I've got a question about, and that is the output of this circuit. The output is taken from here, output, and the input's here. But what if I was to try and take a voltage and use that voltage from, say, this point here? That's the top of the pot at the end of the pot that's floating, or maybe from here, from the adjust point. Would I be able to take the voltage from there, adjust this so I get the voltage I want, so I can take it from the adjust, or from here? Will that work? Is it right? It's not the way the LM317 was designed to work, but let's have a look, let's find out, see if that would actually be of any use or not. So, using this resistor again, I won't change that. I'm going to change it first of all to be on the top side of the pot. That's the first place I'm going to do. So, I'm first going to take my output from this point. Where it comes in, you've got the other side of the pot that's just hanging in the breeze, having a happy time on its own. I'm going to connect it up and draw my power from there and see what happens. So, let's take that out of there, put it into the top end of the pot, and I'm going to still measure the output across the actual output, the correct output where it should be, just to see how that is affected by this circuit. So let's turn it on. Got me 1.22 volts on the output, which is what I expect. Start turning that up, and it's going up. That's 6 volts, nearly 7 volts, 7 volts. Seems to be working all right. And now it's going down. What? I'm at 7.5. And once I get past that, the voltage starts to drop back down as I increase that pot on the adjust down to 1.94. So no, it doesn't actually work very well, because instead of taking it all the way up to its top value, the voltage starts to drop again. So that really doesn't give me a helpful output. I suppose once you get past a certain point, it's dropping all the voltage down to ground, because the resistance is that it's coming through this resistor, through this pot, and once this pot gets so far down, it's going to be dumping the voltage, most of the voltage, directly onto the ground. So that's the only point where you've got a voltage to reference, so the voltage goes down. So turn that off, and now what if I was to put that in the pin for the adjust? Let's get it in there. Now this is in the adjust pin, coming out there. Now this is going to be odd, because to me that wants to be 1.25 volts. So if I have it in there, I can't imagine that that's ever going to adjust from that. So all your voltage is going to be up there, all dumped out of here, isn't it? So that I can't imagine is going to be of any use to anybody. So let's have a look now. So turn it on. Got 1.23 volts, and as I turn it up, it does go up. It's only going up very slowly. I'm at 1.9, 1.93, and that's it. I'm at full. It's not. So obviously I'm only seeing the voltage that it's trying to regulate between the output and adjust pin. So obviously I can't use that as an output either. So to me, what I'm proving to myself here is that if I want an output from the LM317, you have to use the output pin, because that's the way it was designed. Let's put my let's put the LED back in, At least it's a display, then you can actually see something happening. That on in there, get it in. It's my 317. Connect it up to my LED. Turn it on, 1.24. It didn't want to come on until I got to about there we go, about 2.5 volts, and then it just gets brighter and brighter and brighter. There we go. Just put that on top. Save my eyes. Don't know how the camera is reacting to that, but there you go. LM317. A really quite a simple little circuit, a little component. Gives you an opportunity to take a higher voltage and vary it to whatever you want. I mean, this circuit would be quite good if you were wanted to have test a circuit that was, say, 3.3 volts, or you had something that's 5 volts, or something that required, let's say, 7 volts or 8 volts, all the way up to 10 volts really, but you only had a 12 volt power supply. Brilliant. Seems great to me. There we go. LM317. So there you go, the LM317 variable voltage regulator. It's a great little device. It's used in many circuits. If you actually look on the data sheet, you'll see that it's used quite a bit in other types of circuits. It gives lots of examples of different types of circuits you can use them in. There's quite a few manufacturers of the LM317, so they'll all have their own data sheets, so have a look on them and give them a go. Get a few in, try out the circuits and see what you get from it. It's a great device. Anyway, if you happen to like this video, give us a thumbs up, subscribe, and all comments are welcome. I'm sure everybody's had a go, or a lot of people have had a go at the LM317, so yeah, comments please. Well, catch you next time. Anyway, time for a brew and a sandwich. See you later. Well, I'm glad that didn't fuck up recording.